Well, folks, this is March the 2nd, 2021. I'm on Highway 93 with quite a bit of traffic, so it's going to be a noisy video. But today I'm at the 7.1 mile mark. That's 7.1 miles from the Hoover Dam bypass bridge. And what I wanted to do today is look at this road cut through here where you have this lava flow that's 10, 15, maybe in some areas 20 feet thick, that has flowed over this sedimentary formation. And based on my notes, looks like a basaltic andesite. And it's the Pliocene to Upper Miocene period for these basalt flow up here. Andesite flow, it's a dark gray. And the sedimentary rocks below it are Pliocene to Upper Miocene. And the deposits in this area around here, the younger alluvial deposits, or Holocene to Pleistocene in age. But anyway, today what I want to do is walk around amongst all the noise and take a look at this lava and how it has reacted with the lower sedimentary material, which is very interesting. I mean, when it flows over that, it's going to burn that top surface. Let's go over here. You can see there's a big, thick area of it there. But there are parts of this where it's within grabbing distance, the intersection of this lava flow and the sedimentary material, and see how that excessive heat has burnt the sedimentary layer, lower layer there. Again, this is Highway 93 with a lot of traffic. Come over here, see what we can see, and hopefully talk around all the noise. Okay, let's cross the cross street here and come over and see what we can see. It's pretty incredible, the views here. But clearly at some point, right at the very top of the sedimentary material, this alluvium here, you should be able to see where the rock has been transformed. This conglomerate or breccia has been transformed due to the heat that it experienced when this lava flowed over it. I'm going to try and talk in between the traffic, but let's walk down here for a little bit. So what's nice about these road cuts through here, you get to see a cross-section of what has occurred through here. But it's pretty neat. Looking to the east in that direction, and then heading north, sort of north on Highway 93. There are fragments all through here of this basaltic lava here. And then can see it all the way down there. It's pretty amazing. It's pretty high up there, but I think further down it gets to a level where I can see it close up, that boundary between the lava and the alluvium here. Just walk through here. Keep walking through here. There it is over there. More of the same stuff. One thing I do notice, for the longest distance, right at the intersection of this alluvium and the lava flow, the lava gets kind of frothy instead of this platy material. It's real frothy, and maybe I can find an example of that on the ground around here, because they're just rock fragments all over the place. That might be an example there a little bit. That surface, uneven surface, that's right at the boundary. Here's some more here. It has that appearance right there without the trash. I'll get that out of the way. But look at that. Keep walking through here. Okay, I got it on zoom so I can get a little closer view of this lava up here. Just keep going. And again, it's over across the street. This is Highway 93. We're heading north to Las Vegas and Hoover Dam Bypass Bridge. That is just some incredible looking stuff up there. It's dark gray, parts of it are black. You know, it might be some basaltic andesite composition. But here's that frothy looking stuff right there. Right at, you can see it all along. It's right where it's the boundary between this alluvium sedimentary material and where the lava first hits it. And then above it, it's more of a platey looking material. Like that right there. That's interesting. Hopefully you can see that. Close. Huh. Pretty neat stuff here. Here's another look back at the front, zoomed in a little bit. Again, that lower layer right at the top of the alluvium. All this sediment. It's real frothy looking. It's probably a better way to describe that. But it's interesting, it's there, and then it's platier looking above it. Example of this, I guess it's a breccia or maybe a conglomerate, but it's super hard. It is clearly been subjected to the heat because it's a lot harder than the material that's further away from the lava flow. Get a little closer if I can, but that is super hard. It's a mixture of all kinds of different minerals and rocks. Pretty amazing. Okay, coming around. Let's walk over here to the southbound side of Highway 93. Again, here's their view of all this. Here's let me grab this. This is an example of that frothy looking basalt. That's the material. It's not that planar looking material or sheet-like material that's way up higher into the lava. It looks like this right at the surface of the alluvium, the sedimentary layer, lower layer. Kind of neat. Let's go up here for a second. It's nice to get a quiet moment. Okay, this again is the southbound 93 going to Kingman side. But let's walk over back close in here. Take a closer look at this. Getting up a little closer to see all kinds of different aquatic environments. You have layers where it's smaller size fragments in a sandy environment. Then they get really larger through here. They're in a flow pattern. It's like it was a river or something through here, or some sort of a floodplain that was able to sort it out. Here it's real smaller size. Lots of sand through here. And then you just go right up to the lava layer. So back over here. See if we can get up real close. You can see how the environment changes just in this sedimentary formation. Here's some larger fragments all just bundled together. That must be some heavy flash flooding to carry those pieces. This platy material. Quite a bit of it through here. It's beautiful through here. Then it kind of thins out. The lava layer right over here, it's only like 3 or 4 feet thick right through here. Take a look at this real quick. Little light green in there. Pretty neat through here. Okay. Let's see if we can cross the street here without getting killed. Again, this is southbound 93. Run across real quick. This is where the lava is you can get a greater idea of the boundary. Because right down there is the sedimentary formation, so it's just a few feet above the ground. But here's this frothy material right at the surface of the alluvium. This is a good place right here. to look at it. It's just characteristically right above the sedimentary material. Then above the frothy is when it starts to show this platy feature all through here. Yeah, here right at the surface, this conglomerate or breccia is just super hard. I mean, it's been subjected to quite a bit of heat, and so it's now not real brittle anymore. Like you can see, the same material that's further away from the heat zone here it is down in here. All that material there, right at the surface, that boundary has just really been subjected to a lot of heat from the lava. And I think the term that's used, it's a becomes a meta breccia or a meta conglomerate. I don't want to point into the sun too much, but here's this platy material right in here. Here's a big piece of how it's plated out. Up without getting into the sun too much. But that's nice where it's on kind of on the ground level. You can see this boundary here, right in there. Okay, further along on southbound 93. There's this little open area from that mound of lava right in here. This open area, it'd be nice to go up in there and see the extent at which this lava continues on. But I can see over there it's quite a distance further to the west. But anyway, without getting into the sun, well, going back to this boundary area, again, here you got this assortment of all kinds of rock fragments in this clastic sedimentary material. Then right at the surface, it gets real frothy. I know there's probably a better term for that, but I'm just wondering if there was water in this area. A very small amount of water laying on the top here, like a shallow lake or something. Then the lava came in and hit that water when it first started to flow over this material here to get this frothy looking. And that's why it's that way, because it hit water and a rapid cooling or something, and here's some more of it through here. And then all of a sudden it gets real platy right up in here. This is a good place to come and look at this. Again, right along here. It's super hard. It's not soft. When you take a sample from, like on the other side, further away you get from the zone of heat, this plastic sediment material is real soft and brittle, but you have to go a number of feet away. But right at the interface, it's real hard. Then the frothy material, and as you go up, then it becomes more of a platy like look to it. This right. This is a good place where you can see that the transition. Which is the most it's the most interesting part of all of this, is how the lava affects the alluvium material. And right in here again, you can go down and just look at all the different sizes of material. There might have been water here, a lake or something, where water was present, and then the lava just flowed right into the water, and then it gives this kind of frothy look, and then it just keeps going. Then eventually it just burns off the water, and now it's just flowing, free flowing all the way up to the top. Well, anyway, it's just well, there's just so much video you can do through here with all the vehicles coming through. But it's an interesting geological study through here. But anyway, it was a great coming out here. My third or fourth trip. And as you can see, we're looking the wrong way.